before we start 11.7, let's try this warm up for 11.5. So press pause and answer these questions on your own. Okay, now let's take a look and see how you did. We want to find the area of a circle with radius 8 and leave in terms of pi. So area is equal to pi r squared. And remember, you have to memorize that formula. And so we do pi times 8 squared. Make sure you square it and get 64 instead of taking it times 2. And the area is 64 pi, and let's put a label on it, centimeters squared. Area is always centimeters squared. Next, we want to find the area of the given sector of the given sector of the circle. So that angle is 60 degrees over 360 times pi times the radius, which is 4 squared. And let's go ahead and get a decimal for this answer. So we can do 4 squared, which is 16 times pi times 60 divided by 360, and you get 8.38. And we'll just say units squared, or square units for that one. And we want to find the area of the shaded region, rounding the answer to the nearest tenth. So here we have this rectangle, which we can find the area. We'll call that area of the rectangle by doing base times height, or 10 times 24, which is 240. Keep writing 240 there, my apologies, which is 240. And then I can find the area of the circle. I know this whole thing is 10. That means the radius of the circle is 5. And the area of the circle would be pi r squared, or pi times 5 squared. And make sure you do 5 squared, and we'll just leave it as 25 pi. But if I use the area of that circle and just add those together, I'm counting this area twice. And so I really only want to use half of that. So the total area would be the area of the rectangle, which is 240, plus half of the area of the circle, which was 25 pi. And so you can do 25 times pi and then divide it by 2, or take it times 1/2, and then add 240 to it, and you get 279.27. And we'll say units squared. Okay, in this section 11.7, we're going to talk about geometric probability. So probability is a likelihood that something will occur. It can be written as a simplified fraction, a percent, or decimal. So you could say, well, it has a 1/2 chance of happening, or a 50% chance of happening, or a 0.5 chance of happening. And when we do probabilities, we do the likely outcome, or the desired outcome, we'll call it. Desired outcome, or favorable outcome, divided by all the possible outcomes. Okay, and in this case, we're going to look at geometric probabilities, and we're going to start with number lines. So we're going to find the probability that a point chosen at random on point PQ is on RS. So we got to figure out how big is PQ. So PQ goes from -5 all the way to 5. We can see that's a distance of 10. You can count, or you can even subtract 5 minus -5. But that is the total possible outcomes, 10. And then the probability that that point is also on RS, which goes from -2 to 4, that's a distance of 6. So the probability would be 6 over 10. And we always like to reduce that. So we'll make it 3/5. We could also write that as a decimal, which would be 0.6, or as a percentage, it would be 60%. So all those are equivalent. It just depends on what the question asks for. So take a minute to answer these 3 questions. First, when we find the probability that a point chosen at random on PQ is on a given segment. So it'll be helpful to know what PQ is. So PQ is a distance of 10. So that's going to be all my possible outcomes. So I can put everything over 10. And so then simply I just need to figure out how big each of these segments are. RT is just 1, so that'd be 1/10, which is 10%. If I skip to TS, that's a distance of 5, so it'd be 5 over 10, which is 1/2, or 50%. And then RQ would be a distance of 7, so 7 over 10, which is 0.7, or 70%. So those are all my answers expressed as a percent. So that's probability of a number line. Next, we're going to look at the geometric probability with shapes. And so here are some steps. First, we want to find the area of all the shapes shown. We want to add or subtract to find the area of the shaded region. And if we want probability that a point is randomly chosen, lands in the shaded region, then we'll use the probability of, the area of the shaded region over the total area to get a probability. And then last, we're going to express it as a percent. So for these two, we want to find the probability that a randomly chosen point is in the shaded region. So first we got to figure out the total area of this. And this is a square. So 12 by 12. Gives me 144, we'll say units squared. So that's the area of the square, which is the total area. It's all possible outcomes. And then we're going to randomly pick a point. So if I pick this point right here, just randomly, what's the probability that it's in the shaded region? So if I were to just kind of drop a pencil anywhere on that, what's the probability that those points land in the shaded region instead of outside? So let's call this A2 and find that area. It's a triangle, or I guess we'll say area of a triangle. Might be a little easier. That's 1/2 base times height. The base is 12, and the height is 4. Remember, height is always perpendicular to the base. And that would be 24 square units. And so this means the area of the shaded region would be, if I subtract those two and do 144 minus 24, and I get 120 for the area of the shaded region. So that means I can finally say the probability that I'm looking for is 120, which is all the shaded region, over the total region, 144. When I divide 120 by 144, I get 8.33. Repeating, and just move the decimal over 2 spots to get 83%. On number 4, same type of problem, just different shape and different numbers. So take a minute to pause this and try to solve it on your own. Okay, I think we've seen something like this before, where this is 6, and this circle would also be 6, and this would also be 6. And so this is 24 this way, and if I know one radius, I know every radius, so that's 6, and that's 6, and that's got to be 12. So the area of the rectangle, which is all possible outcomes, is 24 times 12. Which is 288. And the area of a circle would be pi times the radius squared, and we'll go ahead and just leave that in terms of pi for now, which is 36 pi. And then there are two of those. So to find the area of the shaded region, I need to take the area of the rectangle, subtract both circles from it. So minus 36 pi minus 36 pi. And that's something you can type in your calculator. And when you do, you get 61.8 for the 8.1 for the shaded region. So the probability that we land in the shaded region is 61.81, the favorable outcomes, which would be the shaded region, over the total area, which is 288. And you get 0.214 or 21.4%. And it's also a good thing to note that probabilities can never be bigger than 1 or smaller than 0. Because if something is bigger than 1, that means it's over 100% chance of happening, which is not theoretically possible. So if you get a number bigger than 1, then check your work. You may have made a mistake somewhere along the line. And that brings us to the end of 11.7. Good luck on the assignment for this section.